Good morning, stellar scientists. I am homesick with a cold, and I cannot return to school until I have a negative COVID test. So, while I am at home resting and waiting for the test results, you will be completing stations to understand how matter influences sound. Please be sure to go through each of the slides in this presentation and complete all of the tasks listed for the day. You may do this on your own or with a partner. I am really looking forward to returning as soon as possible. I'm crossing my fingers for Thursday. See you soon, Ms. Lamott. Here's a quote for you to think about today as you have a guest teacher. I care about decency and humanity and kindness. Kindness today is an act of rebellion. And this is a quote by Pink, who is an American singer-songwriter. For today, you'll need your planner, your notebook, pen or a pencil, and canvas. Please update your weekly agenda, or rather your planner for today. We are working on matter, and if you have time, you can start your 1.4 summary. You may pause the video as I'm going through in order to complete these tasks. That's not supposed to be there. I will remove that. This says to take out your notes. To get us started today, I want you to define 3 vocabulary words and add them to your notes. The first is matter. Matter is anything that has mass and volume, or anything that has weight and takes up space. That's another way we can think about it. So basically, anything that you can touch, feel, see, smell, is made of matter, even if it's too small to see. Mass is the amount of matter in an object, and we commonly think of this as weight. Volume is the amount of space an object takes up. Matter is made of tiny particles that are way too small to see without very special tools. Very, very, very special microscopes will allow us to see some of these tiny particles. None of the microscopes that we have in middle school or even high school will allow you to see these particles. But these particles are always moving, and they're moving because they have motion energy. Pause the video and write these notes down. In general, solids are made of particles with the lowest motion energy. Liquids are made of particles with medium energy. And gases are made of particles with the highest amount of motion energy. Solids, liquids, and gases are a state of matter. Matter, any kind of matter, can exist in all 3 of these states. Some forms of matter, like water, can exist at all 3 states naturally. We can have ice, water, or water vapor, which is water in the gas form. Some of these forms of matter, however, don't exist naturally on Earth in all of these states. However, they can be forced to go into those states if there is enough thermal energy added or removed. So for example, oxygen, a gas that we breathe every day, that's about 20% of our atmosphere. Oxygen can be cooled really to a really cold temperature, lots of energy removed from it, and it can go from being a gas to being a liquid. We call it liquid oxygen. And oxygen can even freeze. We can even have frozen oxygen. It just is so cold, there's nowhere on Earth that exists at that cold temperature naturally. But what I want to point out is that there are no such thing as solid particles or liquid particles or gas particles. Rather, it's matter that is made of these particles, and depending on how the particles are arranged or how much they're moving, this matter is at a different state, solid, liquid, or gas. You can pause the video to write any of that down. All right, so if we were going to zoom in and look at solid water, this here is an image of a zoom in. We do lots of zoom ins in science. We would see that ice, or solid water, is made up of these little particles that are locked together, but they are vibrating in place. So they do not move relative to each other, but they're always moving. There is no matter on Earth, even in a lab, that has ever had no motion. It's impossible so far. It would require very sophisticated technology that has not yet been invented. So these particles have low motion energy. However, they are still vibrating in place, and they are pretty close together. When that water melts and we have liquid water, we see that they're the same particles, but now they're just doing different things. They're not locked together. This is why you can put your hand through water. This is why water will take the shape of its container or spread across the table if you leave your ice to melt. So they are more free to flow around each other. They're still in contact, but they are not locked in place. The particles in a liquid have more motion energy than particles in a solid. All right, now if even more energy is added to this water, we get water vapor or water in the gas form. And that would be up here, and we can't see it, right? We can't see, there's water vapor in the room right now as you're listening to this video. But you can't see it, feel it, taste it, smell it, none of that. The particles making up matter in a gas state are moving freely and independently of each other. They do not have contact except due to accidental collisions. These particles have the most motion energy and are the farthest apart. So what does that have to do with sound? Why are we learning about that? Well, sound is a wave that carries energy through matter. Sound cannot happen without matter. Sound must have these tiny particles because, like with our slinky, sound energy is passed as a wave when particles bump into each other and sort of pass the push of the original disturbance. We can watch this video here and see what that looks like. So this is showing how a wave will travel out in all different directions once a disturbance is added. And it does so in sort of a chain reaction sort of way. So for example, here, notice that as this wave is passing out, this area over here doesn't move until this area here touched it first. Then if we look at this next video, we see more about sound and matter.
When an object vibrates, it pushes the surrounding air molecules into one another, starting a chain reaction of collisions through the air. These collisions travel in waves. When they strike your eardrum, it vibrates. This vibration is converted into electrical signals that your brain recognizes as sound.
So we don't necessarily need to focus on how we hear or perceive the sound. Rather, what I want you to be thinking about is how without those air molecules there, or air particles, or gas particles, whatever space you're in, sound wouldn't be able to travel. The wave itself, there would be no way for that energy to move. Light is a little bit different. Light is also a wave and does not need to have particles, and we can get more into that later. All right, so now you are going to spend some time doing some more learning on your own. If you feel like you really understand all of the things that we have talked about with matter, this is a set of activities that is really fun, and it leads you through a sequence of activities and asks you questions and gives you ideas of what to do. You can absolutely access this. You can just click right here. If you're feeling confused about matter, or you just really like simulations and want to explore more about matter, you can go here to this PhET simulation. It's really fun. Or maybe you just want to learn more about waves in general, not just sound waves, but waves in general. You can watch this Brain Pop video. At the end of class, you are required to complete this exit ticket and tell me what you've learned for today. So this exit ticket here, you can access by clicking the link. All right, scientists, I really hope that I get to be back at school with you tomorrow. But until then, hopefully this video will do the trick. Have a great day.